Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. May all the peace and blessings of the Almighty Allah subhanahu wa ta'ala be on all of us. Now, this is lesson number 2 of electrochemistry. Now, in lesson number 2, we will be discussing about the oxidation numbers. Going to define oxidation number, importance of the oxidation number, rules pertaining to oxidation number. Let's do one by one. Now, what is an oxidation number, class? You see, an oxidation number is the apparent charge that an element has in a compound or the charge on an ion. Pay attention. It is the apparent charge that an element has in a compound. You can have the element can be in a compound. Sulfuric 6 acid, potassium manganate 7, potassium dichromate 6, iron 3 oxide, iron 2 oxide. What is the charge that that element has in that compound? To find out, use the concept of oxidation numbers. Again, or the charge on an ion. For example, we have the ion-like radicals, ammonium ion, hydroxide, nitrate, phosphate, and all those. Now, what is the importance of this oxidation number? How is it essential? Number one, it will tell you the electron movement in a redox reaction. It will help you to keep track of the electron movement in a redox reaction. Point number two, it helps you to understand the naming of inorganic compounds. Again, this one has the rules. Rule number one of oxidation number. The oxidation number of an uncombined element is 0, e.g. in molecules as well in atoms. Oxygen, chlorine, hydrogen, sodium, sulfur, all of them, they have oxidation number 0. The charge on an ion containing one element is equal to the oxidation number of that. For example, magnesium ion, that's 2 positive here. I don't know if you remember lesson 1, we discussed about copper having 2 positive, and we said the oxidation number of copper is positive 2. That is the rule. The charge on an ion containing one element is equal to the oxidation number of that element. For example, this one has a charge of 2 positive, oxidation number is positive 2. 3 negative nitrogen, negative 3. Oxygen 2 negative, negative 2. Hydrogen positive, plus 1. That is it. Rule number 3. The oxidation number of hydrogen in all compounds is contained in it is positive 1, except in metal hydrides where it is negative 1. We're going to come back this. Let's now move on. The oxidation number of hydrogen in all compounds that contain it is negative 2, except in peroxide where it is negative 1, and oxygen fluoride where it is negative 2, positive 2 I mean. Now, in compounds, the sum of oxidation numbers in all the constituent atoms is equal to 0. E.g. this one. In ions containing more than one element, the overall charge is equal to the sum of the oxidation numbers of the constituent elements. Now let's discuss one by one. Basically, we use rule number 5 and 6 in finding the oxidation number of an element in a compound. For example, you may have had, like, let's say you have, if I tell you to name this today, all of you will say iron 2 oxide, right? How is iron 2 oxide coming? Let's do one by one. Now, class, what we know is that iron is, you give it iron 2 oxide. How is that name coming about? Now we do. The first thing you know is this a compound? Yes. What have we said about a compound? The sum of the oxidation numbers in all the constituent atoms is equal to 0. Now, we have iron as unknown. We have the iron as unknown, Fe plus. The oxygen is having a negative 2 will be equal to 0. From there, Fe minus 2 is equal to 0. Therefore, Fe is equal to positive 2. That is why we say iron 2 oxide. On the other hand, we have another scenario like this one. Look at this. If I ask you what is the name of this compound, you say iron 3 oxide. Iron 3 oxide. Now can you elaborate and substantiate for that? Now let's see. You have here, the iron is unknown. You have 2 atoms of iron here, which is Fe, plus 3 atoms of oxygen, each having -2, will equal to 0. Now it becomes 2Fe minus 6 is equals to 0. 2Fe will be equal to 0 over 2 over 2. Now Fe will be equal to positive 3. That is why we say iron 3 oxide, and that is rule number 5. Up to there, are we together? Are we sailing in the same boat? Right. Now, let's come back and look at this. In ions containing more than one element, the overall charge is equal to the sum of the oxidation, e.g., ammonium ion. Let's look at ammonium ion here. Look at ammonium. It's written like this. Right? Now let's check how is that coming about. Let's find out the oxidation number of nitrogen. N plus 4 hydrogen. Each hydrogen has positive 1. That is the oxidation number, except in metal hydrides, where it is, we're going to see how it's going to behave, is equal to the apparent charge. The sum of the oxidation number, of the constituent element is equal to the apparent charge on the ion. Is equal to the overall charge. Very good. It becomes positive 1. Now it becomes N plus 4 is equals to positive 1. So N will be equal to positive 1 minus 4, which is N will be equal to -3. And we know that nitrogen has an oxidation number of -3, and that is correct. This one well substantiated for. Another one, if you want us to look at, for example, let's look at sulfate. SO4 2 negative. Now we say S plus. We have 4 atoms, each having a -2 will be equal to -2. Now it becomes S plus S minus 8 is equals to -2. S is equals to -2 plus 8. S is equals to 6. That is it. The sulfate. You do it like that. You won't find the oxidation number for that. Now class, you may have seen a lot of elements being called. For example, we have sulfuric 6 acid. Is written as sulfuric 6 acid, H2SO4. We say sulfuric 6 acid. Now I want to prove that 6 today. How is it coming about? We know the oxidation number of hydrogen is positive 1. Now we have 2 hydrogens. 2 into bracket positive 1 plus the S is unknown. We want to prove if it is really 6 or not. Plus 4 into bracket, each has -2, shall be equal to 0. Because rule number 5. Rule number 5. You say in compound, the sum of the oxidation number in all the constituent atoms is equal to 0. And this is a compound, and this is a compound. Now it becomes 2 plus S minus 8 is equal to 0. Now it becomes S minus 6 is equal to 0. S is equals to 6. And therefore, you can see that sulfuric 6 acid and these things is very correct. Let me show you another one. Potassium dichromate 6. Potassium dichromate. Potassium dichromate 6. How is it going to be? It is, you're having K2Cr2O7. That is the chemical formula for potassium dichromate 6. Now we want to look for the oxidation number of that. What do? We have 2, and we know the oxidation number if this is positive 1 plus 2Cr plus 7 into bracket -2 will be equal to 0 because it's a compound. Now it becomes 2 plus 2Cr minus 14 is equals to 0. 2 minus 2Cr minus 12 is equals to 0. 2Cr is equals to 12 divided by 2 divided by 2. Now we can see that chromate is 6. Take it back there. Potassium dichromate 6. And more we will be doing in our next lesson. Solving 3 and 4, which has some special cases. Wish you all the best and have a blessed day. All the best.